The universe is full of surprises. In 2020, astronomers announced a groundbreaking discovery, the South Pole Wall. This massive cosmic structure, hidden behind our own Milky Way galaxy, challenged our understanding of the cosmos. The Discovery team, led by Daniel Pomeridi and R. Brent Tully, used a technique called redshift velocity mapping. By analyzing the motions of galaxies, they were able to map the distribution of matter in the universe. This led them to the South Pole Wall, a sprawling structure of galaxies stretching across an enormous expanse of space. Its discovery sent ripples through the scientific community, prompting a wave of new research and speculation. The South Pole Wall is not just big, it's significant. It's part of the cosmic web, a vast network of filaments and voids that make up the large-scale structure of the universe. These filaments are like highways of galaxies, strung together by gravity. The South Pole Wall is one such highway, a massive concentration of galaxies and dark matter spanning hundreds of millions of light-years. Its discovery reinforces our understanding of how the universe is structured. It also provides crucial clues about the nature of dark matter, the mysterious substance that makes up the majority of the universe's mass. Understanding the South Pole Wall could help us unravel some of the biggest mysteries in cosmology, from the formation of galaxies to the ultimate fate of the universe itself. The South Pole Wall is truly colossal. It stretches for at least 700 million light-years across the southern celestial hemisphere. To put that in perspective, that's about 14,000 times the size of our Milky Way galaxy. Imagine a string of galaxies stretching across billions of trillions of miles, and you start to get a sense of its scale. Located about 500 million light-years away, it's relatively close in cosmological terms. However, it's hidden from our view by the bright light of our own galaxy, the Milky Way. This is why it remained undetected for so long, despite its immense size. It's a stark reminder that there's still so much we don't know about the universe. Section 4. Unmasking the invisible. Detecting the South Pole Wall. Detecting something as vast and distant as the South Pole Wall presents a unique challenge. Astronomers used a clever technique called redshift velocity mapping. This technique relies on the fact that the universe is expanding. As the universe expands, galaxies are moving away from each other. The farther away a galaxy is, the faster it's moving away from us. This motion causes the light from distant galaxies to stretch, shifting it towards the red end of the spectrum. By measuring the redshift of galaxies, astronomers can determine their velocity and distance. By mapping the velocities of thousands of galaxies, the team was able to piece together the presence of the South Pole Wall, revealing its enormous size and structure. Section 5. Mysteries of the Universe. Future research and discoveries. The discovery of the South Pole Wall has opened up a new avenue of research for astronomers. Studying this massive structure could provide valuable insights into 1. The nature of dark matter. The South Pole Wall structure is influenced by the gravitational pull of dark matter. Studying its shape and dynamics can help us understand the properties of this elusive substance. 2. Galaxy formation and evolution. The distribution of galaxies within the South Pole Wall can shed light on the processes that drive galaxy formation and how they evolve over cosmic time. 3. Cosmic expansion. The South Pole Wall can be used as a yardstick to measure the expansion rate of the universe and test cosmological models. The South Pole Wall is a reminder that we live in a vast and mysterious universe. As we continue to explore the cosmos, we're bound to uncover more such surprises, challenging our understanding of the universe and our place in it. Its discovery reinforces the importance of continued exploration and the power of scientific inquiry to unravel the mysteries of the cosmos.